SKF launched a system for investigating loads in continuous casting machines called Caster Analyst. In order to avoid bearing overload and extend the operational time of the roll lines, it is essential to understand the load distribution in the machine. With Caster Analyst, you can detect incorrect roller settings and, therefore, avoid damage not only to the rollers and bearings, but also to the slab, saving large amounts of money by reducing production losses and equipment damage. With Caster Analyst, it is also possible to shorten the startup time of new machines and to better optimize the casting speed. Many roll line failures are caused by overload, the introduction of cooling water or dirt into the bearings, or by a combination of these events. To achieve an even load distribution in the roll line, it is crucial that the rollers be mounted correctly. This can be very difficult to achieve. First, the rollers have to be mounted accurately within each segment, and then the segments have to fit precisely together in the strand. With Caster Analyst, it is possible to detect many scenarios of incorrect roller mounting. We will now show some examples of these scenarios. When the roll line is mounted, the taper setting is an important consideration. The taper is set according to the shrinkage of the slab. This is a complex task since shrinkage is taking place throughout the entire machine and is influenced by cooling and casting speed. The correct taper setting is important since it affects the quality of the slab. A damaging slab could be the result of an incorrect taper. On the one hand, if a roller is mounted too high, it will get overloaded. On the other hand, if a roller is mounted too low, the rollers next to it will get overloaded. A bent roller can cause large variations in the load distribution. This can give overload to both the roller as well as to the bearings. All these types of misalignments in the roll line geometry can have major influence on the internal quality of the steel, since inclusions can be created in the slab. A slanted roller does not necessarily affect the quality of the slab, but it does generate an axial force in the roller, which may lead to bearing overload. If a roller is blocked, for example because of a bearing failure, the slab may become excessively scratched. This lack of quality either leads to production losses or machining of the damaged slab. In the worst case, a blocked roller might even cause a breakout. In some situations, the load distribution is especially skewed. This might be the case during the startup curve and the run-in period, but may also occur during the beginning of the casting when the dummy bar is pulled through the strand. The exact effect on this is difficult to know without understanding the load distribution. Caster Analyst is a good tool for gathering information about the effects on the roll line in these situations. The SKF Caster Analyst consists of 3 different units. The bearing housing electronics, or BHE, where the actual measuring takes place, the roll stand electronics, or the RSE, and a software solution to view the results online. A BHE unit can have up to 8 channels. Today, 2 channels are used for measuring loads and 3 channels for measuring temperatures. The other 3 channels are reserved for future use. The BHE unit consists of a microchip, a flash memory, and an AD converter. All the startup calibration data, together with the ID of the unit, is stored in the flash memory, making it traceable with all the data retained at any given time. The BHE unit is placed inside the bearing housing, which is then secured against the intrusion of water and steam. The BHE is connected to the RSE unit with heat-shielded wires. The analog measuring data is calibrated and transformed into a digital signal within the BHE. This way, the signal stays uncorrupted and is not affected by heat or electrical disturbances. Each RSE unit can control up to 6 BHE units. If a BHE unit gets too hot, the RSE will shut it down to protect its electronics. And since the ID and calibration data are stored locally in the BHE flash memory, there are no problems for Caster Analyst to start it up again when the temperature goes back to normal. The last RSE in the chain acts as communication node to the Caster Analyst computer system. When booted, the system is self-configured, showing the number of RSE and BHE units, each with a unique ID. If a unit, for any reason, is not correctly connected, it is automated. Caster Analyst shows load and temperature data as online results. All measures are recorded by Caster Analyst and is accessible and viewable at any given time. Here we see an example of the load history in one of the housings. And here, similar example, but this time of the housing temperature. A powerful tool, which shows an overview of the measured load in a specific housing, is the histogram view. The histogram gives a trained eye a quick assessment of the load situation in a row line. When the load histogram looks nice and smooth, like in this image, everything is in order. But if the histogram should look differently, there are several reasons to examine it closer. The temperature data can of course also be represented in the histogram view. Another way of viewing results is with a load spectrum and a list of peak loads. The load spectrum can give hints and warnings to possible row lines. For instance, if a peak load appears with a frequency that corresponds to once per roller lap, it is an indication that the roller is bent. And, depending on the load amplitude, it is possible to judge how severe the misalignment is. As you see, the SKF Caster Analyst is easy to use since it is self-configured and has full traceability. All data is temperature corrected, and since it is digitized directly at the source, the quality of the signal is maintained and can be fully trusted. We see Caster Analyst as a first step towards monitoring the caster process and as a tool for continuous improvement. We are convinced that the interpretation of the load sensing results, in combination with our bearing knowledge, will help you improve your casting process and the efficiency